What's up, guys? So we're moving on further, Unit 5, 5.3, and we're going to be talking about a big one that's going to be moved on into Algebra 2, into Calculus if you take it, and also whenever you go to college, if you take a college math class, this theorem is going to be included in almost everything that you do. It's going to be something called the Pythagorean Theorem. You guys have probably already heard it before, but we're going to go over it again. We're going to do some more application with it, and I hope you guys will like it. Okay, let's jump into it. All right, so first thing we're going to talk about is specifically what is the Pythagorean Theorem. So it says in a right-angled triangle, meaning the only way that this is going to work is if it is a right triangle. It cannot be any other triangle. It has to be a right triangle. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So basically, a squared plus b squared is always going to give you c squared. So that means if I was to square the hypotenuse, add the square of the other two sides together, they're always going to be equal to each other. Okay, so let's go ahead and look at it and kind of some aspects we're going to end up doing over here. So right now, the thing you always need to understand is the hypotenuse is always going to be the c value, the longest leg. I need you to listen to me here. The hypotenuse is always going to be opposite of your right angle. So find your right angle. The side opposite of that is always your hypotenuse, is always your c. So whatever number or whatever value, variable, anything that is the hypotenuse is always going to be plugged into your c value, okay? Now the other two sides are going to be known as your legs. So we have leg 1, leg 2. It doesn't matter. They're both your legs. It does not matter where you plug these into the problem. This leg could be A or B. This leg could be A or B. As long as you plug them in for A or B in both of those, it's going to work out. This is the Pythagorean Theorem. So what I'm going to do is I'm going to jump over to the examples, and we're going to actually apply this theorem and find out how to use the Pythagorean Theorem. All right, so the first one we're looking at, example number 1, it tells us to find the missing side length. Well, I know right now that this is a right triangle. So the first thing that should be popping in my head is, oh, the Pythagorean theorem can be used with a right triangle. So I can go ahead and look and do a squared plus b squared equals c squared. Since I know the value of two sides of my triangle, I can use Pythagorean theorem to find that third missing side, which I know opposite of my right angle is going to be my hypotenuse. So this is going to be my c value. It's going to be my hypotenuse. So that is what I'm trying to find. And again, the two legs, it does not matter which one's A and which one's B as long as you plug them in. Okay, so let's go ahead and look at that. So right now, I'm going to go ahead and call this A. I'm going to go ahead and call this down here B, and we're going to plug it in from there. So right now, A is going to be 5. So I'm going to do 5 squared. B right now is going to be 12. So I'm going to do 12 squared, and then I'm going to do C squared because I don't know what the C value is right now. Okay? So 5 times 5 is going to give me 25. 12 times 12 is going to give me 144. I'm going to add these two together. It should give you 169 c squared. Now, I'm not done yet because I got to get rid of that squared symbol. The opposite of squaring something is square rooting it, just like on our simplifying radicals. So I'm going to take the square root of both sides. That's going to cancel the squared. So my c, the square root of 169, is a perfect square, which is going to be 13. So your final answer for that missing third side is going to be 13. And just so you guys know, if you were to do this radical and it doesn't come out as a perfect square, you then could simplify it. You could simplify your radical just like the last lesson that we did here. Okay, so let's jump over to example number 2. So right now in example number 2, it tells us to find the missing side length. Again, we're given two sides. I need to find that third one. I know it's a right triangle, so that means I can use Pythagorean theorem. So right off the bat, go ahead and identify the hypotenuse. That's what I always do. So go ahead and identify. Opposite of my right angle is always my hypotenuse, always my long side, always my c value. So that's going to be the c value is my hypotenuse. So now that means these other two sides are going to be A or B. It doesn't matter how you label them. So again, I'm going to label this A, I'm going to label this B. So I know Pythagorean theorem, a squared plus b squared equals c squared. So let's go and plug in my info and then solve for it. So a is 9, so I'm going to get 9 squared plus b squared is going to equal 15 squared, okay? So 9 times 9 is going to give me 81, b squared, 15 times 15 is 225. I'm going to subtract 81 on both sides, so that cancels. So I'm going to be left with b squared equals 144. And then to find b squared, I have to take the square root of both sides, which then b is going to end up being 12. Okay? So your final answer for the third missing side is going to be 12. Okay? All right, looking at example number 3 here. So on example number 3, it tells me to find the missing side length again. So on this missing side length, again, I know it's a right triangle. So if I'm given 2 missing sides, I can find that third side by using Pythagorean Theorem. So right off the bat again, opposite of my right angle is always your hypotenuse, always your C value. Now the missing legs, it doesn't matter how I label them, it can be A or B. So I'm going to label this one A, I'm going to label this one B. So let's go ahead and use Pythagorean Theorem to solve for that missing side, okay? So right now A is what I'm trying to find, B is 10, and C is going to give me 26. So A squared stays the same, 10 times 10 is 100, 26 times 26 is going to give you 676. I'm going to subtract 100 on both sides, which is going to give you 576, okay? And then I'm going to take the square root of 576, and that should end up giving you A is going to turn into 24. So I took the square root of both sides. So A is going to end up being 24 because the square root of 576 is 24, because 24 times 24 is 576. All these are coming out to equal perfect squares, okay? So now lastly on example number 4, it gives me a right triangle and I need to solve for x here, okay? So right now, what I can do is I can plug everything in. But what I'm actually going to do is I'm going to find this missing side length and I'm going to set that equal to it and then I'm going to solve for x, okay? So I'm just going to treat this as if it's a missing side that I'm trying to find. So right now, using Pythagorean Theorem, my right angle, opposite of that is going to be my hypotenuse, which is my C value. And that means my other 2 sides are either A and B. So I'm going to call this A, I'm going to call this B. So now I'm just going to plug in everything and solve it. So right now I'm trying to find A. I have my B value, I have my C value, okay? So 16 times 16 is going to give you 256. 20 times 20 is going to give you 400. I'm going to subtract 256 on both sides. Which is going to give you 144. And then I'm going to take the square root of both sides, which A is going to end up giving you 12. So right now, it's wanting to find the value of x. So if the whole side is 12, I know this whole thing is going to be equal to 12. So x plus 9 is equal to 12. I'm going to subtract 9 on both sides, so x is going to be equal to 3. So your final value is going to give you 3, okay? So ladies and gentlemen, this is a brief explanation on how to use Pythagorean Theorem. Hop over to your skill check. Let me know if you have any questions.